So we're going to talk about transformer connections here, and now this is going to start taking the combination of all the other videos that we did. So I got to give credit where credit is due, and most of these diagrams come directly from the SEL 587 manual. So let's look at the next page, and we're going to take the same transformer and we're going to break it out and show you how you get from this business to that business, okay? And this is probably one of the hardest things that most people don't know how to do. And remember, the easiest thing to do is just to go ahead and start right on our Y, and let's bust out all of our neutrals and get that identified first. That's pretty easy. There, done. All right, now we need our phase connections. This is little a. This one's going to be little b. And then this one's going to be little c. And now we need to identify our primary. So what I'm going to do on the primary here is I'm going to go ahead and do another color. And we have our A phase always comes out. And you can see right here, this is the polarity dots that I was talking about. They're on both sides. I don't need to point those out anymore. I just want you to notice that they're there. So we have A phase here, then B phase is here, and C phase is here, right? So then where are our negative polarities hooked up to? Well, remember what we said was this is a DAC transformer. So our A phase connection right here is going to connect on A phase coil and on the C phase coil, okay? And we don't want to hook it up phase to phase. That'd be a short. So it needs to go to the C phase negative polarity, okay? And then I'm going to put a little connection dot right here. And then we have the next one's going to be our negative polarity of A phase connects to positive polarity of B. Well, that's pretty easy. You just do right there. And then this one right here, done. All right, so we've got that figured out. So now let's take a look at our delta, okay? There's two ways of viewing this. What we really care about is what are our line voltages here and here, okay? And I say that specifically because that's going to matter later. So first, let's go ahead and identify that this is a 4-to-1 transformer. We're just going to say that it is. It doesn't really matter. Really, you can count the number of coils here, and you can be nitty-picky, and you can say that this is a 1-to-1. I don't really care. Let's just go with this right here. And so if we say that we're inducing on the delta side is 480 volts, right? Then what's our secondary? Well, that means that this coil gets 480 volts. It's a 4-to-1 coil, so that means that this coil outputs 120 volts, and I'm going to put this in purple, so that way it matches all the rest of our conventions here. 120 volts, and then our phase to phase on the secondary is going to be from A phase to B phase. And remember what we said before, if you have a Y like looking like this, right, our square root of 3 video, our voltage from here to here is the square root of 3 times larger than that. So that means that our voltage from phase to phase is going to be voltage phase to phase is equal to 208 volts. All right, so I'm just going to write that there, and we'll do that. Well, I'll show that again later. But that's all of our voltages on this. Now, the last thing that we need to know is what's our phase shift, right? And that's this stuff right up here. Okay, so let's go ahead and figure that part out. Now, let's start with the primary side, and we're going to draw this triangle. Okay, and so this triangle is a delta. Now, when you hook this up to the back of a relay, the relay doesn't really know anything. It just knows that you made a connection here, a connection here, and a connection here, and it measures voltages between them, and it just imagines that there's a floating ground between them, and it's going to assign a floating ground voltage. Now, is it measurable in that relay? No, because ground is not really existing, right? This ground does not exist. But I just want to use this as a reference because it'll help us a little bit when we're trying to identify our Y side. Okay, so when we're looking at our Y, now remember this is VA on the primary, and then this is going to be VB, and this is VC. These are all capital letters. And then on this right here, what we're going to do is we're going to look at the secondary. Now, what is the secondary? Well, on this coil right here, this coil is V little a. So this is it's going to be V little a. It's also, you can name it as VA, and the other side of that coil is Vn, so minus Vn, right? Same thing as writing Va to N, all right? So, but neutral is 0 volts. So let's just say that it's Va, because you could write it as Va minus Vn, which is equal to Va minus 0 volts. So you could just write Va. So let's just, I say that now to pregame later because we're going to come back to that, and we're going to run into this a few times. So when we look at this is VA on this coil. What's the primary coil? Well, the primary coil is hooked up to what? It's hooked up to our A and our B voltages. Okay? And so if we look at our A and B voltages, this is going to look like VA minus VB, which is the same thing as VA B. Okay. Now that we have that, let's take this and let's superimpose our secondary on top of this. So we know that VA is equal to VA minus VB. Okay. So if we are VA, V little a, we're going to go all the way up. So VA is up here, right? And then VB is out here, but we need a minus VB, so it's the other direction, right? And so when you add these two phasors together, this is called a vector sum. You're going to do VA and then minus VB, right? The total sum of those vectors is right here. And so this is V little a. All right. And what you'll notice is that there's a 30-degree clock shift here. Okay. And that's our 11. Okay. So this one right here is at 12 o'clock. So that means that this one right here has to be the other one, which is our A phase on the primary to A phase on the secondary, and this is our 11 o'clock. Okay, so that's how you get that. So the other ones are going to look just like this. So let's just go ahead and let's just write them out real quick. B and VC, and then I'm going to go ahead and we're going to change our colors again. We got equals, V. Now which ones are which, right? VB is right here. And this one's going to come from VB and VC. So VB minus VC, and then VC is right here. And this is going to be VC minus, and if you trace it out, it goes all the way up here to VA. So now we have that one, minus VA, capital A. All right, so now we have all of those figured out. I'm probably going to have to erase this upper one right here because I might run out of real estate, but let's go ahead and take this, and we're going to move let's do our VB now. So VB is, you start at VB, so we go all the way out to VB, and you minus VC, which is the opposite direction of where C is. So we start at the center and move towards where C is, which is the same thing as doing this, right? Which is, that's just this right here, but we need the negative, which is out here, okay? So then the total for this one is going to be right here, okay? And this is V little b. I'm going to get rid of all this business right here. And then where's VC, right? VC is going to be VC minus VA, or V little c is V big C minus big VA. So we're going to go down here towards big VC, right? And then minus VA. Well, VA is straight up, so V minus VA is straight down, which is right here. And we're going to have that. So the resultant vector is about right here. And I'm just going to do it like that because I don't want to, I'll just redo it a little bit right here so it's out of the way. It looks like this, and this is V little c. So now let's go ahead and let's go back to looking at our delta, okay? And I'm going to, redraw that out here. And then I'm going to take my delta and I'm going to redraw my triangle back out right here like this, okay? I'm going to get rid of all of this. And now look at that. Doesn't this look like this delta right here? I mean, even the corners line up. And then this Y is exactly like that Y right there. Okay, so that's how you get from one to the other. I didn't say it was going to be easy. And remember, this voltage right here is 120 volts on each one of these legs, right? And then even though this delta is smaller, it's just smaller because of how we drew it. Really, if this length right here is 120 volts, then the 480 is much bigger, right? But these from phase to phase, it's 480 volts, right? And then from phase to phase on the Y side, remember, we don't want to lose that one because that matters too, right? Got a lot going on this thing now. This is going to be 208 volts. Okay. So that's how you get all of the voltages. And if you wanted to draw them and play with your relay diagrams, and you want to look at your vectors and compare them and understand how the clock shifts relate to this, and then understand your transformer connections, where it's the H1 to H2 or H1 to H3, this is where all of it comes from, and this is the culmination. So the next videos that we're going to do is going to be over the DY1 and then the YD11, and then we'll do one more video over the YD1, and then just an easier one over the DD0. We don't need to do a YY0. It's just wasting people's time. So see you in the next video. Thank you.